topic. So right now we are discussing software design aspect of this. And then today's talk, I'm going to talk about object-oriented design. Now, object-oriented analysis and design is a popular technique, especially when we use object-oriented programming languages to model a software system. So programming language like Java is very popular, and the technique is used like we are going to look at everything as objects, right? So many programmers like object-oriented methodology because it's modularity, reusability, and maintainability. So because of these reasons, object-oriented code is very popular among the programmers. So I already told you, like, we are going to use objects, and this particularly object could be a person, a place, event, or even a transaction. Now, let's say we have a situation where a patient is going to meet a doctor. So when you take a patient, it is an object. When you take a doctor, again, it's an object. And when you take the appointment, that is also an object. So this is how we are going to model it. So now when you look at any interaction, something like this, as an object-oriented in view, right? So we can see object as their function and they interact. So when you perform object-oriented analysis, finally what you're getting is we call object model. And this could be used to represent the information system using objects. And at the same time, there are some concepts that we are going to see are also used to represent the information system. Right. Now let's briefly talk about what objects are. As I told you earlier, it could be a person, a place, or an event, or a transaction. What you see in object is it has data as well as processes. So for example, if I take a customer, we can have the data part of it, like name, address, account number, current balance. And then there could be some set of functions, right? That means these objects can perform some task like, oh, okay, you can place an order, you can pay a bill, or even changing your address. So in this particular example, you will see a parent object. So you will see a parent and there could be a set of attributes as well as method. And then we talk about something called instance, right? So based on this, when you're creating parent object, so we have for each of these attributes, we have a set of values. Now, similarly, in this example, you will see a child object. So there are three parts: the child object, the object name, then you have a set of attributes, and then the methods. So each of these attributes, you can have some value. Here is another example which shows you the dog object. Right. Now let's look at the attributes. So when you want to describe an object, we use attributes. So you can sometimes get these attributes from coming from inheriting, for example, from parents to child object. And you can acquire. Then each object you have what we call the state. So what it means, for example, if you take a student in the university, we have a future student, a current student, past student, and so on. Similarly, if you take a bank account, it will be active, it can be inactive, closed, or frozen. So you can see here the comparison of two objects. We have student object and instructor object. So you can see the three parts, a student, attributes, and set of methods. And this one also you have instructor, attributes, and the methods. Here is another example. We have fitness class schedule object. Again, you have three parts: name, set of attributes, and the methods. Another example, registration record object. Again, you can see the name, attributes, and the methods. Right. Now, when you say a method, that means some functionality, right? So any function that perform a particular task, you have to have set of steps. Now, for example, assume that the function is you are going to have more fries. So to have more fries, now we can use steps, right? We can use these steps. Another example, for example, adding a student might consist of set of the steps. So you list them all. The third thing that we are going to discuss other than the attributes and the methods is the messages. So messages can tell, right, what a particular method should do. Now, for example, in this example, we have add student and delete student. Right, here we have seen two methods, add and delete, and this is how it looked like. Right, now that we have talked about the messages, and when you send in messages and when objective receive messages, when you start with, let's say, good night, might post to something else in the other classes. So that's why it said you can use the same message. And when you have two different objects, you will have different results. Right? So this idea is known as polymorphism. So you will have many forms. Right? So when you say good night to a parent, which causes the parent object to read a bedtime story. If that is for dog, you cannot force dog's object go to sleep and forces the child object to get ready for the bed, right? So you can see different objects receive different results, although you call the same. Next, the classes. Now, when you have set of objects, when you put up into a group, usually we call a class. So when you have object and when object belongs to the same class, remember that you have common attributes and the methods. And within the object, you can also create subgroups or subclasses. Okay, so let's look at some example. So according to the example given here, you can see a class vehicle. And there are subclasses like car, minivan, truck, school bus, right? And then the vehicle, you have a set of attributes and the methods. Subclasses have their own set of attributes sometimes. So whatever the attributes here, we will say common attributes. Whatever the methods here, we can common modules. So if you're here, for example, unknown or uncommon attribute. Right. Another example, we have employee. Under the employee, we have manager, office staff, and instructor. Again, you can have common name, common attribute, and you have common method as well. Right. Now, when it comes to classes, one thing you need to remember that can belong to more than one category. So this is called superclass. So for example, here, we know the instructor is an employee as a person. So the class is in the middle and the subclass is to the right and to the left is the superclass. Right. Now, when you say a relationship, it could be the object need to know about they know each other, and then how to object responds to changes in other objects, right? And affects the membership in classes, superclasses, and subclasses. And when you say inheritance, it's enabled the object called a child to develop one or more of its attributes from one another object. So this is called a pair. So you can see here, in parent is the one, and then we have child. So here we have see we have a blue color box where we have a list of attributes and then the methods. Right, now let's identify the object classes relationship. And this is called object model, right? Now, for example, in this example, what you see is object model. All these are considered as object. But there are special cases. Now, for example, the manager, office staff, and instructor are equally important for employee. So here we have employee is a manager, and manager determines the fitness class schedule. And then here what we have is a registration record. And then we have office staff. And then we have instructor. Office staff usually for administrative. And instructors we are going to have to assign when they are free. And then once you do that, you will create a registration code, and that will map to fitness a class and then student. So a student can take the fitness class. So in simple terms, what we try to understand here is, object model, you can present their complex relationship. And then we can also discuss how it relates. Right. The next one is we are going to look at some of the technology developed under this. So UML, for example, is widely used for visualizing and documenting. And here we will have use cases, use case diagrams, class diagrams, sequence diagrams, state transition diagram. So you might not need everything, but depend on your requirement, you have to use. So this is one. Usually we start with the user cases. Once the user case finalized, we can get one user case at a time, then we can implement. So that is what quite popular nowadays. Right, now let's look at an example of use case diagrams. So use case diagram will show you the dynamic behavior, especially when you want to capture the requirement. Right? So here we are using a stick figure. So in this case, you can see a patient, a doctor, and then they are going to have an appointment. The arrow indicates the direction. So here is a more complete example, right? So we have passenger make airline reservation, customer place order, bus dispatcher change address. Right. The next one. Now, when you look at the relationship with these actors and user cases, you can actually combine. And the relationship between two cases labeled with either users or include or extends. So users include relationship indicates a use case is needed by another in order to perform a task. Then the second one, extend the relationship indicates alternative options under certain use case. So UML indicates a relationship with the arrow that points to those that points at the use case being used. So the first one, if you look at it, we have a student at business class and the schedule should be empty. Then we have use cases. First of all, when you ask to write a use case, we have to start with the information. So especially we have to focus on the requirements. And then here we have to identify the actors, the stick figures, and the functions. And then for each, you have to describe the use case description. So here is an example. In this user case, you can see add new student and the name, actor, description, completion, successful, alternative, pre-production, post-production, assumption. So there are many things that consider. So when you look at visual diagram, we use case diagram is a vital summary of several related classes within the system or subsystem. Right. So there are three things we can talk about. Identify the system boundary, place the user case on the diagram, then add the actors, then show the relationship. So here is another example. So one thing to note, this square shape actually indicates the information system and the users are outside. Usually, whoever is actually coming from this, putting up maths and all, you can see that it's towards them. So you start with the rectangle shape, writing down everything and try to solve them. Right, here is another example. Some more examples. Now, for example, if you're using Agile, so maybe you are not going to include everything. So as a second phase, you can get it here. We have here another example. In this use case diagram, you can see there are 5 users. We have management, we have a salesperson, we have customer. Okay, customer, we have a separate relationship. So customer can be divided as a new customer and existing customer. So in the next, we have to talk about the class diagram. Usually, once you have the user diagram ready, you are supposed to come up with the class diagram. So the class, we have a rectangle. And then you can put the name at the top and then individual classes, attributes, and methods. So the second one, use lines to show relation between the classes. Then place labels to identify the actions that repeats two classes. then describe how instances of some one class relate to instead of another class. So let's look at some symbols. So the main one is you have to get. So we have UML notation, for example, there are slight change. Usually you have minimum and maximum in case of your family with that use. So in UML notation, star marks means any. So the first one, it says the minimum is 0, maximum is any number. Second one, minimum 0, maximum 1, 1 on and only 1. Okay. Then we have lectures. In this case, we have one to many. So it's a slightly different approach, but I think you better know this as well. So based on the previous, this is what they have came up with, a manager, right? And here are the tables and table relationship. Right. Now, for example, let's look at some of this. Now we have a sales manager, and then one side we have a sales rep. So what these two numbers means, the sales manager managing 0 sales or more. So now you can see in this one sales manager can have 0 more sales reps, but sales rep you have one manager. Similarly, staff office also we have one. The next one you can see here, customer. They are signing for the particular order. And then finally you get the order. Another example from Namathi's book, the latest version. So you can see how they have modeled using aggregation network. Another example where we have bank account in the middle, the customers transaction, everything is outside. Then we have another example. In this one, we have person, employee, customer, and then per employees. And then we have person, employee, customer, because employee customer could be a subclass of person. And these are like, I think, I guess, might be friends. Right. The next one is the sequence diagrams. Now in class diagram, we don't see actually when something happens, at what time. So another example is you can draw sequence diagrams. So in sequence diagrams, what we do, we are going to consider all the classes, and then for each classes, if possible, we are going to have them parallel. Right? So this is what we have. We have two classes, class 1A, class A. The dash line is a lifeline, and then you have a force. So more detail, the classes, we can identify classes using a rectangle. And then classes we send or receive message are shown in the top of the sequence diagram. Lifeline indicated by the dash line, the literature presents the time during which the object above is able to interact with the other program languages use cases. Then messages. They can be identified by the application. And then finally, we have focus. So let's try to understand this with a simple example. You have a couple of objects: student, manager, fitness class schedule, registration. So when the student requests the class information from the manager, manager will ask that class receive value. Then if that is the case, you can notify again. And this time you can see student to manager, and then manager send the payment to the payer. Another example. Next, we have state transition diagrams. What state transition diagram means, the object can change from one state to another. So for example, when you take a bank account, so initially when you create the bank account, it will be a new bank account. But then you ask to have annual excess, right? Existing. We have active one. Then there are two places you can go. One is custom bank concept. And then we have active, existing. We have asset. We have frozen. Their assets are released. Another one is activity diagram. So here we will have activity diagram where you have a lot of activities. For example, in this one, we have customer. He needs cash, then go for ATM. Then card is 2040. And then PIN is customer question and cash. ATM update balance, ATM provide the cash, and ATM notify the customer. Right. Now, these are the things that I wanted to discuss in brief. So, based on what we have discussed today, I want you to work on this problem. So, first we'll start with the user case diagram. And in user case diagram, have at least two authors. Then you are going to create a use diagrams. Right. Now let's put this in the chat. So I put it in the WhatsApp. Right. So the next one is putting you up in groups. So we have 12, 3 each will create. Right. Now this is what you need to do. First,
Resume. So the first part actually you have already done in your previous one. So let's discuss the next subtopic on software re-injury impact. Now, when we talk about the financial analysis tools, we discuss how the cost and benefit lies, especially when you create a software. You spend a lot of money in the beginning, and after that, you have some maintenance cost, and later on again, the cost will be increased. The reason is when it comes to the software getting old, sometimes you have to, your maintenance cost will be high, or you have to, switch from one to the other one. So in this part, we are going to look at, different issues arise and how, software re-engineering actually used. Now, when we have the software applications, we create software applications for organization needs. So whenever the organization those changes, we need to change the software as well. So software reengineering is the way of actually changing the software, right? And then reengineering can you can rebuild expensive or obsolete legacy systems, right? Now, when you talk about what is software reengineering, we are focusing on the reimplementation, especially when you have old legacy system for maintenance. So when you talk about reengineering, we are going to talk about a couple of ideas: redocumenting, restructuring, translating to, of course, for modern programming language, or you may update the system data. So by doing so, within the software reengineering, we improve the system structure, documentation, and understanding. Now, why we need it, right? So you know that the business will change, and whenever there are changes, it may lead to new software requirements. So what happens when you are over the years, the software becomes complicated because you might actually adding features and removing features. The maintenance will be a bit difficult with the time, right? So if you look at the maintenance ability, it's difficult, it's proportional, and also it's proportional to the maintenance cost, right? So what happens? Generally, you have to decide whether to continue with the old system or are you going to replace. So the next thing that we are going to look at is software reengineering strategy, right? So one of the challenges in software engineering is how do you implement or manage when you change legacy systems. Now, when you look at different ways of changing software, we can talk about software maintenance, architecture transformation, software engineering. Software maintenance doesn't usually involve major architectural changes that we don't consider as a re-engineering. Then we have maintenance type, preparing software codes adapted to the different environment, adding or modifying functions. So those are like software engineering. Now you look at kind of errors that you will see or you will notice. Usually we will see uh, most of the time the errors based on the requirements. So initially if you are not capturing the requirements correctly, then later on once you build the system, correcting those requirements are very difficult or it will be very expensive. And also you need to change external internal factors. And it is reported that usually about 20% of maintenance are fixing mistakes, and the remaining is adaptation, enhancement, and re-engineering for future use. So, what do you mean by this legacy system element? After repeated correction, adaptation, and enhancement, software becomes unsettled. So this is what will happen when you are using a software for a long time. Maintainability is the issue. So more maintenance, which means that you have to have more unexpected side effects. And despite function, its maintenance cost increases and its value decreases. Then the second one is source code translation. Automatic translate source code from one program into another. Why? Hardware changes, policy changes, lack of software support for some of the programming languages, improve system stability, testability, and maintainability. Right. Now, reverse engineering, we will talk about analysis of software to recover. What do you recover? The design and the specification. So it can be used to understand the program before reopening its structure, not always followed by revision. Process of reorganizing program to collect related parts into modules. Like different modules are there. We call program modules, data abstractions, hardware modules, functional modules, and process support modules. So process there when you talk about the data engineering, it's the process of analyzing organizing data structures and values. Can be necessary due to the data degradation, inherent program limits, and architectural evolution. So let's look at now forward engineering and re-engineering. Forward engineering start with system specification and with the new system. Re-engineering start with an existing system and with the transformation of the old system. So finally, conclusion. Now, re-engineering is necessary, especially when it comes to old systems. So the different activities are there, and these activities are source code translations, reverse engineering, program structure improvement, program modularization, and data reuse. Okay, so that's all what we have for today's session.